Hi class. So the best way to learn Lewis acids and bases is by doing exercises. So let's work on exercise 1. It says identify the Lewis acid and base in the formation of water. So the setup for these kind of examples is going to be the same. There's a question, and then you have the chemical reaction, and then something called the Lewis dot structure. These are used for organic chemistry. It pretty much is letters, lines, and dots, and of course some positive, negative signs. Now, notice how the hydroxide ion has 6 dots. These dots represent electrons, electron pairs. That's why they're grouped in twos. So 1 electron pair, 2 electron pairs, 3 electron pairs. Hydrogen ion doesn't have any electrons because remember, to become positive, a hydrogen atom has to lose an electron. So electrons at negative charge, that's why this one's positive. And since the hydroxide ion has an excess of electrons and this one has none, hydroxide ion is going to donate a pair of electrons to the hydrogen ion. So this pair is going to be shared, donated with the hydrogen ion. As you can see on the water molecule, instead of having 3 electron pairs like we did in this one, now we only have 2 because this one is the shared, it's called the covalent bond. It's a bond between oxygen and hydrogen. So in a way, you can just pay attention to which one has the most dots. Like this one has none, and this one has 6 dots or 3 electron pairs. That should give you a clue to say the hydroxide is going to donate a pair of electrons to the hydrogen. So for Lewis Lewis acids and bases, a Lewis base is the one that donates the electron pair. So we can write OH minus, which is the hydroxide ion, is the Lewis base. And H plus, which is hydrogen ion, is the Lewis acid. Remember, hydroxide ion donated the pair of electrons to hydrogen, so pair of electron donor, pair of electron acceptor. Lewis base, Lewis acid. Now let's work on another one that doesn't have hydroxides in them. This one says, identify the Lewis acid and base in the reaction between ammonia and boron trifluoride. So you have ammonia, boron trifluoride, and then you get this molecule right here. So again, you have the Lewis dot structure. Notice how we have an electron pair with NH3, which is ammonia, but we don't have any with boron trifluoride. So these electrons, or this pair of electrons, is going to be shared with this molecule. And they're going to create a bond, which is going to look like this, as you can see. No, we don't have any, they're called lone pairs. No more lone pairs of electrons. And now we have a big molecule. So ammonia, NH3, donated the pair of electrons. So as per Lewis, NH3 3 is the Lewis base. And BF3 is the Lewis acid. Remember, the one that donates the pair of electron is going to be the base, Lewis base, and the one that accepts that pair of electrons is going to be the Lewis acid.